All in this video, we are going to learn about prototype tooling. So this is a series in rapid manufacturing. So the first thing which we are going to learn here is the application level, which is nothing but the indirect processes. Because of marketing reasons and in order to indicate the manufacturing speed, some call it as indirect rapid prototyping process as well. For the same reason, in literature, sometimes the term secondary rapid prototyping process is used. So this is an indirect process because of which we say it as indirect. So indirect prototyping. Indirect prototyping is applied to improve additive manufacturing parts, properties in order to fulfill the applicator's requirements. If the additive manufacturing part is not capable to do so, say for example, a flexible part is needed, but due to material restrictions, it cannot be built directly by an additive manufacturing process. So then what we will be doing is like then a geometrical exact but rigid additive manufacturing part is built and may be scaled according to a possibly shrinkage during casting and used as a master model for a subsequent or flow-up casting process. As a detailed surface is required and the parts are mechanically loaded during the copying procedure, mainly functional prototypes, preferably made by stereolithography or polymer jetting, are used as masters. They have to be manually finished before copying. The majority of parts made by indirect processes are functional prototypes and consequently have to fulfill the same requirements. Solid images or concept models are rarely made by indirect processes because the higher effort in terms of time and cost can be typically justified. So we know that additive manufacturing is a process of rapid manufacturing and rapid prototyping. Many different secondary processes or indirect processes can also be applied. The most prominent one is so called as room temperature vulcanization (RTV). It is also called as vacuum casting or silicon rubber molding. So if we want to develop a shoe, a sole of the shoe, then we can use silicon rubber molding. There will be a setup, and based on the setup, the impression will be obtained for different sizes of the slippers or the shoes. Like silicon rubber molding, most of the secondary processes are completely or partially manually or are partially done using manual processes with long cycle times and therefore only useful for small series or number of different types of productions. As they are prototypes made from prototype material, the system elements are no series products, even if they function well. Prototype parts from soft materials, for example gaskets, often have a very complex shape. This is especially true for gaskets for car mirror fixation that must fulfill many functions such as a sealing against water, fixation of the mirror and parts of the window, placement of cables, and also the optical appearance. Indirect tooling. Indirect tooling is based on the same copying procedures as all indirect processes. In rapid prototyping and tooling, it is not the goal to obtain a final part but a tool that provides the basis for a small or medium size batch production of final parts or even the products. It is the process of not only making the final part but maybe one part but in a perfect manner that can be applied or fixed in a car or many other big industries. In contrast to series tools made from tool steel, it can be made quickly and inexpensively. Like indirect prototyping, indirect tooling uses additive manufacturing masters and it avoids milling, grinding, and EDM processes. In contrast to silicon rubber molding, it must be usually used for a large number of parts made not only from plastics but also from metals as well. So indirect tooling or rapid manufacturing, additive manufacturing can also be done for metals, steels, and aluminums and strong materials. Seen from this perspective, indirect tooling can be regarded as an element of rapid tooling, although it is not a layer-oriented process. As an example, a mold for making wax patterns for lost wax casting. The mold is obtained from a additive manufacturing master by counter casting it in polyurethane PUR, and it is backed up by an aluminum box. After the additive manufacturing master is removed, the mold is used to process the required amount of wax pattern. So we shall continue in the next video. See you in the next video. Until then, it's bye from Radhika.